we can go with some calculations from equation using the mole. So yeah, so we can go from for some calculations. Okay, calculations involving the moles, number of moles handled. Okay, see what an equation tell you, like see, for example, you write an equation, C plus O2 gives CO2. Okay, see here actually, suppose if one carbon atom is reacting, one carbon atom react with one molecule of, one molecule of oxygen, it gives one molecule of carbon dioxide. Okay, suppose if you are taking in the terms of moles, so here actually one mole react with the one mole of oxygen, it forms one mole of carbon dioxide. Okay, and suppose if you are talking in terms of mass, think that you are talking in terms of mass. Okay, see here actually one mole of carbon, it is actually 12 gram, and one mole of oxygen, it is going to be 32 gram. So 12 gram of carbon, it can react with 32 gram of oxygen, it is going to form 44 gram of carbon dioxide. Here you should understand one point. See, what is 12 plus 32? This is going to be 44. How much amount of carbon dioxide formed? So that is also actually 44. So how much amount of reactant is there in the mass? How much mass is there in the reactant side, and that much of a product is also there in the reactant, and that much of product also is going to form. So actually 44 gram of carbon dioxide. 44 gram of carbon dioxide, it is carbon and oxygen. Mass of carbon and oxygen is going to be 44. So the amount of carbon dioxide formed is 44 gram. Okay. So this is something, this is on reality you can understand. And now, what can I say? Now, so these are some of the very important relation. Actually, like suppose if you are counting it in terms of a number of atoms or molecules. So this is going to be one atom. It reacts with one molecule of carbon dioxide, and it is supposed to form one molecule of oxygen. It is supposed to form one molecule of carbon dioxide. So this is the ratio. So so in terms of moles also you can count. In terms of moles also, it is possible for you to count. Suppose if one mole of carbon is reacting with the one mole of oxygen, it is going to form one mole of carbon dioxide. Okay. So this is again in terms of mass also you can count. One mole of carbon, its mass is going to be 12 gram. It is going to react with the one mole of oxygen, that is going to be 32 gram. So this is going to form 44 gram of carbon dioxide. Okay. So this is what it is. And if you are writing another reaction, see actually H2 plus Cl2, 2HCl. Okay. See here actually, suppose both are gases, all are gases. So actually here one mole of, suppose you are taking in terms of mole, one mole of H2 react with one mole of Cl2, it is going to form 2 mole of HCl. Or else if you are taking 2 gram of H2, it react with 71 gram of Cl2, it is supposed to form 73 gram of HCl. So this is the ratio. Or suppose if you are counting in terms of let it be molecule. So one molecule of H2 react with one molecule of Cl2, it forms 2 molecule of HCl. Okay, so this is the reaction pattern it is supposed to follow. Okay, now we can go with some questions. Suppose if I ask you 2H2 plus O2, it is supposed to give 2H2O. If I am asking you, see this is actually 4 gram, and this oxygen, it is going to be 32 gram, right? So 32 gram. So, how much mass of water might have formed? See, please remember, there is one law called law of conservation of mass. That is called law of conservation of mass. According to law of conservation of mass, you know, mass of the reactants, sum of mass of the reactants, it is going to be mass of products. So, here, see 4 gram of H2 is supposed to react with 32 gram of oxygen. So, this is supposed to form, 36 gram of water. Okay, 36 gram of water. Okay, so this is what you need to know. Okay, and yeah, so this is one thing you can understand, and suppose you are here it is a 2 mole of H2, 2 mole of molecule react with 1 mole of, in terms of moles, if it is 1 mole of oxygen, 2 mole of, it is supposed to form 2 mole of water molecules. Okay, and there is again one more relation we can say. See, here it is a 2 mole, right? So 2 mole, that means I will write the equation here, and 2H2 plus O2, it gives 2H2O. Okay, so here it is, actually this is 2 moles, so that is actually 2 into 6.023 into 10 raised to 23 number of particles are there. Here actually 1 mole, so it is a 6.023 into 10 raised to 23 number of particles will be there. Actually here it is 2 into 6.023 into 10 raised to 23 number of particles are supposed to be there. So if you are taking this reaction, actually it is supposed to have 2 Avogadro's number of particles. Here it is going to have 6.023 into 10 raised to 23 number of particles are there. Here it is going to have 2 into 6.023 into 10 raised to 23 number of water molecules it is supposed to be there. So a particular chemical equation, you can derive number of moles, how many number of reactants supposed to be there, and suppose if you are calculating in terms of molecule, number of molecules, and next one, next quantity what you can find is mass, and next one, number of particles. So let it be molecules, or let it be atoms. Actually, number of moles you can find, number of molecules you can find, mass you can find, okay, and number of particles also you can find. So this is it about, this is the peculiarity about like a particular chemical equation. Chemical equations, it tells you like lot of information in terms of mass, in terms of molecules, in terms of number of moles, like in terms of anything. Okay, so and one more thing, like when reactions involving gases, it tells you the okay. So we can work out from some of the equations, and let's see how it is coming. See, for instance, let it be iron. So one of the question it is given to you. So it is actually iron. It reacts with the copper sulfate. So it is supposed to form FeSO4 plus C. Okay. So let it be for this reaction, according to the question, it is 1.4 gram of iron. It reacts with copper to form 1.6 gram of copper. So what you can understand about this is, see, 1.6 gram of iron. So this is supposed to be, so the molecular mass of, atomic mass of iron, it is iron, it is going to be 56 gram. So copper atomic mass is going to be, atomic mass of copper is supposed to be 64. Yeah, 64. So let's calculate the number of moles of iron in this. Number of moles of iron. So this is going to be 1.4 divided by 56. I don't know how much you will get. So let it be, I will write more clearly. Number of moles of iron. So this is going to be 1.4 divided by 56. Number of moles of copper, it is going to be 1.6 divided by 64. So you will be getting around, okay, so you shall be getting 0.025 moles of iron, it will give 0.025 moles of copper. Okay, so if I write an equation, so the ratio of copper is to ratio iron, it is actually 0.025 is to 0.025. So this is actually 1:1 ratio. Okay, so this ratio is nothing but 1:1 ratio. What you can understand about this is actually how can I say? Yeah. So iron, see here one thing for this reaction, Fe plus CuSO4. So this is supposed to give FeSO4 plus Cu. So this could be, there is a possibility that this could be Fe2SO4. Fe2SO4 also there may be a possibility. Okay, so here actually FeSO4, Fe2SO4 thrice. This also has a possibility. Okay, so why, how we can know that this reaction is going to form only FeSO4? See, the ratio is, the ratio copper is to iron ratio is actually 1:1. So in the product, so that means, one copper it is reacting with the iron. One copper it is reacting with the one iron. Okay, so this is supposed to be FeSO4, not Fe2SO4. Okay, so many calculations we can derive from our equations. Many calculations involving mass, number of particles, so many things, it is easy for you to comprehend from the equations, if you are able to know how many moles, how many mass it is formed, and you can simply tell what molecule it might have formed if you just to measure it. Okay.